our recording here. And yeah, so let's go get ahead and get started. I have a terminal window over here. We'll use the terminal window to type in the commands. I have my own printed paper up here, so I'm not going to be going back and forth between the problems on the page over here and the terminal. I'm just going to do things in the terminal, but you should be double checking whatever that I'm typing in to make sure that it follows along with what is on the actual quiz. So again, starting with those first four lines that are the same for everything. We're doing problem 1 right now. Make dir quiz, cd quiz. And we just created our empty folder for ourselves. And then we have this cat command with this new syntax, the greater than sign, again, doing output redirection, and the less than signs doing input redirection. And here this EOF, again, stands for the end of file, and whatever comes between this EOF up here and whatever I put later on is going to be passed to the cat program, which will output it to the foo.py file. And so here we have xs equals x times 2 for x in 4, 5, 6. Hope there's no typos. Print xs equals xs. I guess I had actual double quotation marks there on the quiz, but it's Python right here, so that won't matter. It'll be the same thing. And so this is the contents of our file right here. I'll again just do an idempotent command. Always fine to do idempotent commands that don't actually change anything, just to help us debug. Here's the contents of the foo.py file. And now we can actually run it to get the final answer. Python 3 foo.py. And here is the correct solution. As long as you have a list in this order, 8, 10, and 12, you get full credit. Anything else, not full credit. So again, how this operation is going, we have this as our starting list right here, started off as 4, 5, 6. Here's the operation that we are doing for each of the entries in this list, calling the entry x. We're just multiplying it by 2. So 4 times 2 gives us that 8. 5 times 2 gives us the 10. 6 times 2 gives us the 12. Any questions? Okay. So problem 1, again, 8, 10, 12. Cool. So yeah, last time I used the reset command to sort of clear my screen. Another thing that I like to do sometimes, if I don't necessarily want to get rid of everything, but just still have a clear separation between what I was doing before and what I am doing now, I'll just hit enter a couple times. And then whenever it's easy for my eyes to just see, there's this big green block that kind of separates the previous from the next stuff. And that's especially useful when you're like scrolling through things. Finding that big green block is really easy to do while scrolling. Just hit enter a couple more times for good measure, and on to problem 2. So cd arm-rf quiz, make dir quiz, cd quiz. And then another cat foo.py EOF. And here inside of this we have, and there's a lot of stuff here, so I should be careful. Filter lambda x colon x less than 5 map of lambda x colon x plus 2 comma range 10 1 2 3. And I think there's no typos here. The parentheses match. There's 3 over there, 3 over here. There is a typo. Ah, yes, I forgot the B before the D right there. Any other typos anybody sees? Okay, hit enter, and then print xs equals xs. Whoops. So I missed one line right here. I forgot to convert this into a list first. I'll go ahead and press the up arrow on my keyboard. If you press the up arrow with these multi-line commands, it'll bring the whole thing back. And now here I can add the, Actually, that won't work. So I'll press Control C to end that, and I will use Vim to edit this real quick. Add XS equals list, XS like that. And 1, 2, 3, that is the same. :W, Q to save. Just cat it for good measure so that we can see if there's a typo. And Python 3, final answer right here, foo.py, hit enter. That's what you should get as your final results. The key, there's a lot of things going on in this problem. The first one is these lambda, again, anonymous functions. This right here is an anonymous function that adds 2 to whatever gets passed to it. So for each one of these things in this range right here, we're adding 2 to it. So instead of going from 0 to 9, we'll go from 2 to 11. And it's very important that you think about doing this, doing the map before doing the filter, that you have to follow the order of operations with the parentheses, doing the stuff on the inside before doing the stuff on the outside. So we do this first, and then we'll do the filtering on the lambda, getting only the things less than 5. So this right here takes away the 0 and 1. This right here takes away everything else. So 2, 3, 4 is what we get. Any questions on this problem? Okay, problem number 3. So CD arm-rf quiz, make dir quiz, CD quiz, cat into foo.py, and we're gonna do XS 1, 2, 3, GF foo of y, colon, 1, 2, 3, 4, XS dot append of y, 1, 2, 3, 4, return y, and then foo of 5, and then print sum of XS equals sum of XS. And I don't think there's a typo there, but somebody should shout it out if you see one. And now let's go through and actually run this, and we'll see what happens. And our final answer here is 11. So what's going on here? Again, this is testing the local versus global variables. That inside of this foo function, we have access to all the possible variables that are outside of the foo function, like this XS function. And if we had said, so I'll open this up in Vim for a second. If I had said something like this at the beginning, because XS right here appears to the left of an equal sign all by itself, then this creates a new local function, and this would be modifying that local function. But because this right here did not exist, this XS right here refers to the global variable up here. And so when we append y, we're actually appending to this list up here. And so this 5 right here gets added to this list. So 1, 2, 3 is 6 plus 5 is 11. And that's how we get 11 as the final answer. Any questions on problem number 3? Yes. For this right here? Yeah. So the question is, you can explicitly say that a variable is global using this global keyword. The answer, you don't need it though, that by default, as long as something does not appear to the left of an equal sign, it is going to be global. You would only need this if something does appear to the left of an equal sign and you want it to still be global. But by default, anything that doesn't appear to the left of an equal sign will be a global variable inside of the function. Good question. Any other questions? Yes. The question is, how come it doesn't return y also? And the literal answer to this is that it does in fact return y. This foo function right here, when we hit return y, this does in fact return 5 because 5 was passed in up here. So this whole thing, this whole expression, anytime you have a function call, it gets replaced by what the return value is of the function. And so this will get replaced by 5. But that's just like having a 5 on a line all by itself, and Python doesn't do anything with something that's all by itself. We're not printing the result of this foo anywhere. If we had changed this to something like print foo equals like that, then it would print the 5 number. Good question. Any other questions? Yes.
I'm a bit confused. We had like access to equal to empty brackets inside the function, and then we did access to append. Does that mean when we print some access, it would only return the one element, or would it return access to the?
Yeah. So we're gonna put 2 print statements in here. Say this one's inside foo, this one's not in foo. And we're gonna see what the difference is between these 2 things. So I've made 2 changes to this file. I've just added this line right here. This change right here is going to force this to be a local variable that is different than this XS up here. And then I'm printing out the contents of that local variable. So those are the only 2 changes that I've made. We'll see what happens. I'll go ahead and cat that to the screen so we can reference it while we look at the output. Python 3 foo.py. And we'll see that inside of the foo function, this line right here corresponding to this line right here, inside of the foo function, we only get 5 as the output because the only entry inside of this list right here is what gets appended here, which is 5. When we do the append right here, it affects only this list, and this list only exists inside the foo function. It is different than this list out here. And so when we leave the foo function, when we're done with the foo function on this line, come down to this line down here, this XS refers to this one up here. Did that answer your question? Yeah. Great questions. Any other questions so far? Okay, last problem, and I'll go ahead and reset for this. So cd arm-rf quiz, make dir quiz, cd quiz, and then get init, that's our line 5 right there. We have 3 echo lines, so echo print hello world, like that, into foo.py, and it's only a single greater than sign on this first print, line 6. Then we have an echo print hola mundo in double greater thans into bar.py. And then we have an echo print. Here I'm using the backslash here with the quotation mark, escaping this quotation mark. So the quotation mark is literally what's going to get printed. It is not the end of the string. Hola otra vez, like that, into bar.py. And it's important that we're paying attention to the greater thans over here, that this one is a single greater than sign, this one is a double greater than sign. So this one is going to overwrite whatever change happened in this command right here. Hit enter. And now git add foo.py and git add bar.py. So we've added both of the files to the staging area, and git commit -m first commit. And now git knows about both of those 2 files. If I run git status right now, we'll see that there's no files down here that git is concerned about. There's nothing in red or green. It's saying there's that git knows about all the changes that you've made. Now we run git branch foo, git checkout foo, echo print hello again into foo.py, git add foo.py, and git commit -m second commit, like this. And so we're just to finish up line 16, 1 line to go. At this point, one of the differences between this problem and last problem is that, or last week's problem, is rather than going back to the master branch, we're staying inside of the foo branch right here. We've committed right here while we've checked out the foo branch. We're staying in the foo branch, not going back to the master branch. So none of our changes are going to get undone. the contents of our directory here is just like if we had never run any of the git commands and only run the echo commands. And so before I run the Python 3 bar.py, let's just take a look at the contents of that file. And we can see down here that the only thing is the hola otra vez. This didn't affect bar.py, only these two files affected it, or only these two lines, and only the last one's important because it's the one that has the single greater than sign, which deletes the contents before actually writing to the file. So now when I run Python 3 bar.py, the output is hola otra vez. And so if you wrote that, you get full credit. If you have anything else, then no credits. Any questions about this problem? Yes.
I got this wrong, but how was the assumption that bar.py wasn't in the directory, so we called Python 3 bar.py after checking out the foo branch that it like wouldn't run bar, but why did it?
Yeah, so the question here is this bar.py. Inside of the foo branch on this line right here, we did git checkout foo, and then we never did anything to modify or create a bar.py file after this. So the question is, why is this bar.py, like where does it come from? And the answer is that whenever you are making a commit, this commit right here not only will have the changes that you just made, but also all of the previous changes that you've made. And so this is one of the previous changes that we've made. And so it's going to contain that change as well. Hopefully that answers the question. Yes. Question is up here, what exactly are these escape characters doing? So again, an escape is anytime you have a backslash before something, we call that an escape character. And the motivation for this escape character right here is because if the alternative to typing out this, I'm just going to type that right now and hit enter. The alternative to putting this escape characters, let's imagine we have no escape characters for a second. Now this quotation mark, this first quotation mark will be ended by this quotation mark right here. So those two quotation marks will match and those two quotation marks will match. And so the echo command will not actually print any quotation marks. If I do that, you see there's no quotation marks in our output here. And so in order to actually tell the echo command that we don't want to just end the previous quotation mark, we literally want to output a quotation mark, you have to put a backslash in front of it. And these backslashes work the same way in both the terminal environment and in Python, and basically every other programming environment that exists. If you're ever in a string and you need to talk about like the actual quotation mark character, you always do that with a backslash in front of the quotation mark character. And that's, again, true in every programming language works that way. Yes. Yeah, and so great question. Follow-up question is, with these other echo commands up here, we have two different types of quotation marks. We have the double quotation mark on the outside and the single quotation mark on the inside. And because these types of quotation marks don't match each other, the terminal knows that this is not the end of this quotation mark, and it will just put a single quote inside of it. So the most common way when people are trying to put quotation marks inside of a string, the most common way to do that is just to make sure that you're using the opposite type of quotation mark to contain the string. But sometimes that's not an option because maybe you need both a single quote and a double quote. Or some people just prefer putting a backslash in front of it, and it's never wrong to put a backslash in front of it. Yeah, so you can only do the backslash double quote like that. There we go. Back to our original one, what I was trying to type. It's never wrong to put a backslash in front of the double quote and use the double quote on the outside. That's exactly the same final output as this. No difference in the end result between these two things. Good questions. Any other questions? Yes. Question is, if line 15 and line 16 did not happen, how would that affect bar.py? If line 9 and 10 had not happened, how would that affect the output over here? And the answer is that we wouldn't actually see any difference in the output the way this particular problem is structured if line 9 and 10 were both deleted. The reason for that is because we would not have these files in the first commit right here, but they would get added to the second commit down here, so they would still be available. Yeah, if anybody has more questions about the different variations on this problem, I'm happy to work through that after class. Those will probably require us retyping things in to see what's going on. So I'll delay that till after class. Go ahead and total up your points and make sure that I get your copies of the quizzes. Any other quizzes? Okay. Today in class, there's a new notes packet for next week's quiz. That's where we're going to start going over. Before I do that, just a quick announcement about the lab is that the lab is not posted yet. I'll post that before Friday, before our actual lab sessions. But in our HTML validator assignment over here, there's going to be a slightly new way of running tests that you haven't done in the previous homeworks, and you probably haven't seen it all in previous classes. Those tests are contained in this tests folder. It's a more advanced way of running tests. More complicated tests will get run. And so the lab is going to be about how to do those tests. So it's okay to start on the homework assignment now if you'd like, but just know that the lab will cover how to actually evaluate whether you have the homework correct. Another note about let's go over to that folder, CMCI topic 2, like that. We were talking about last time the stack.py file. There are two functions inside of this file, and we talked about this first function using these print statements, these idempotent debugging commands that just tell us what is the status of our code so that we can follow through, see what are the values of the variables at different points. I encourage you to do that same thing on this balanced parentheses 2 function. Again, the difference between these two functions is that this second one handles multiple types of parentheses. The first one only handles the actual parentheses, not the square or the curly brackets. The layout of these two functions is very, very similar. You'll see that if you work through it, everything's exactly the same except for the conditions and the if statements right here. Those are the only two things that are different. And so when you're working on your final homework assignment, you don't have to structure your code in the same way that I've structured my code down here in these two problems, but you could structure them in the same way, where the only difference is basically the contents of these if statements. Again, your homework is validating HTML, making sure that every opening HTML bracket has a corresponding closing one. And so this first problem, balance parentheses, only had one type of thing that it's balancing. This balance parentheses 2, a little bit more complicated because it has 3 types of things that it's balancing. And your homework will be even more complicated because there's an infinite number of things that are balancing. So you'll have to be able to match these things, these conditions on an infinite number of ways. Any questions? Let's see if people have content questions about that. Happy to answer that after class today or during lab. But any administrative questions about what to expect? Okay. The rest of today, we're going over this notes packet right here. We're also, the purpose of this notes packet, these quiz practice problems, is that we're going to eventually start talking about how long it takes for an algorithm to run. And this sort of preliminary counting practice problems is our stepping stone for talking about how long it takes an algorithm to run. We'll see that the algorithms that you're implementing on this homework assignment are going to be pretty efficient. There's sort of not really like a way to screw up the efficiency unless you're really trying. But next week's assignment will also involve stacks. And if you don't do next week's assignment the right way, thinking about runtimes and efficiencies, then it's going to be really, really slow. And so it will fail test cases based on the speed of the assignment. The stuff that we're going to talk about today is going to seem fairly like abstract and mathy. There's going to be a lot of arithmetic, just adding things up, multiplying that we're going to do today. But again, the purpose is to get us ready for talking about the runtimes of algorithms. This is sort of like the simple stepping stone for the runtimes of algorithms. Before we do that, in order to actually talk about the structure of these problems, there's 2 new bash concepts, 2 new shell terminal concepts that we have to go over. And then we'll go over the actual Python material. This first line over here, you'll notice that it has these semicolons inside of it. And semicolons are a way in the shell or many other programming languages to combine multiple lines together or multiple commands on a single line. And so here there are 4 commands between these semicolons, 3 semicolons separating out 4 commands. And you'll see that those 4 commands are the exact same 4 commands that we had at the beginning of all of our previous problems. The cd, rm, make dir, cd, cd, rm, make dir, cd. I've just combined them all into one command to make it a little bit easier to parse what's going on in the problems here. The second interesting thing is on line 2 here, I have an equal sign, n equals 8. And this is actually creating a variable inside of the terminal. So I'm going to switch over to the terminal here for just a second, and we'll do some examples with both of these concepts and see what's going to happen. So first, just again, with the semicolon, I can do echo hello and echo world, and it'll print out 2 separate times on 2 separate lines. Or I can do echo hello semicolon echo world like that, and it'll do both of those commands one after the other. So the semicolon just lets you combine multiple commands together in one line. The equal sign, just like you might expect, lets you create a variable, and it assigns the whatever's to the right of the equal sign to this variable, n equals 8, like that. In order to use this variable, it's a little bit different than Python. If I do something like echo space in, it's just literally going to print the value in down here. In order for the terminal, in order for the shell to know that this is a variable over here, you have to put a $sign in front of it. $sign in like that. And when I do that, you can see that it actually prints the number 8 down here because up here we said n equals 8. So anytime you see a $sign in the terminal, you know that that's not actually like the literal $sign in. That is a variable, and the value has been assigned somewhere previously. For the quiz, all of the variables that I'll be giving you will be powers of 2, so like 2, 4, 8, 16. We'll be doing some basic math with those numbers. And so again, the powers of 2 to get you comfortable with doing the math with powers of 2. When you're using the variables like this, you don't have to just have the variable printed by itself. You can say something like echo hello $in world like this, and it will substitute it in the middle of that. You can also have it inside of double quotation marks, and it will do the substitution inside of double quotation marks. But in the shell, there is a difference between double quotation marks and single quotation marks. If we have single quotation marks, that means the variable substitution does not happen. We just get the literal $in. But if we have double quotation marks, the substitution does happen, and it actually puts in the number down here. Any questions so far? Okay. This $sign notation is super common when programmers are just like typing to each other. It's very common to say like if a disaster has just happened, pray to $deity. This is not like a variable that anybody has created. This is just whatever your deity happens to be. You would substitute it into an expression like this and get the command that is appropriate for you. So that's a very common one that people say to each other or type out to each other. Another one is very common for people to talk about like $OS for like whatever operating system you're using, or yeah, it's just very common for informally when people are typing like on GitHub issues, you'll see a lot of $things, and that just means that it's like we think of it like a variable that's appropriate to that particular person. Okay. So now we're ready to start talking about the actual like Python that's going on here. Oh, maybe, yeah, we'll run through this actual first example here, and then we'll talk about the Python in detail. So I'm just gonna type this out, and so cd rm-rf quiz makedir quiz cd quiz like that. And it did all 4 of those commands for me. ls, there's nothing here. ls is idempotent, so I can always run that. Do the in equals 8. And actually, while I'm talking about the variables, one last very common mistake with variables in the shell is to add spaces around the equal sign here. The Python does not care about white space within a line. So in Python, you can add spaces around there. The shell does care about white space. And so you cannot say something like in equals 8. If you do something like that, you'll get weird error messages. So it's always, anytime you're creating a variable, no spaces to the left or the right of the equal sign. For the quiz, that's not going to be important, but eventually you'll be having to write your own shell code, and you'll have to keep that in mind. So that's just line 1 and 2 here. Now on to this third line. Cat into foo.py eof, and start off with count equals 0 for I in range. And here we have the $in right here. This $in is coming from right here, $in. And so this is actually going to get substituted with whatever the value is for in up here. We'll see that in a second. We'll do count plus equals 1, and then we just print it out. Print count equals count like this in EOF. And I'm gonna, before running this file, I'm going to just output the contents of this file, cat foo.py. And here you can see that this 8 did get substituted for the $in. So this EOF behaves sort of like the double quotation marks and not like the single quotation marks. Variables do get substituted inside of this EOF. Before running the foo.py and talking about the Python, any questions about any of the terminal stuff that's happened so far? Yes. Question is, what if I literally wanted to add a $sign into my file down here? And in order to do something like that, you'd have to put the backslash in front of it to escape it. So you can create files that have a literal backslash or a literal $sign in front of it. Extremely rare to want to do that, but if you'd have to put a backslash in front of it to do that. Okay, so for the Python down here, anybody want to shout out what count is going to be right here when I run this? It's going to be 8. And for these very simple for loops like this, it's easy enough to just realize that this line is going to happen exactly the same every time it gets ran, and it's going to happen 8 times. And so we just know that the answer is going to be 8. What we're going to be seeing, though, is that we're going to encounter much more complicated for loops, and we're going to see some patterns for how we can do the computation of those for loops without actually having to step through all of our lines one by one to do these operations. So the next more complicated example, this first example up here has only a single for loop. This second example down here has 2 nested for loops, a for loop here and an inside for loop, this for j in range in as well. I'm going to come back over to the terminal. I'll use Vim to edit this file. Just coming right here, I'll press the lowercase o to send me onto a new line and insert mode for I in range 8 again, and indent that. This is a j. And now when we run this inner for loop, this inner for loop is going to happen many, many times. That this line right here will get executed 8 times in total, 1 for each of these, the times that this for loop goes through. So this for loop right here is going to get executed 8 times. And this line right here will get executed 8 times for each one of the times that this for loop happens. Well, the very first time we go through here, when I equals 0, j equals 0, we'll execute this, do all of this for loop once, then I will increment, then we'll do this for loop again and redo this line down here. I'll run this just so we can see what the final number is, and we can see that we get the number 84, or sorry, 64. The general pattern when you have nested for loops, general pattern, in order to know how many times does this line get executed, is that you multiply the number of times that both for loops will be executed. So here, both for loops are $in right here, so they'll have an 8. So the general pattern is multiply to get the number of times the inner line is executed. And hopefully if you work through a couple of examples, that'll make intuitive sense. And so here, when we do the $in times $in, $in times $in, then it's 8 times 8 times 8, which is maybe not instantly obvious to you all at this point that this is 64, but by the end of the week, after working through a bunch of these, it'll be obvious. 8 times 8 is 64. Any questions? Sorry, yes. So the question is, what about 3 nested for loops? And that's the next case down here. So here we have 3 nested for loops. And yes, the answer will be that you multiply all 3 of these things together, that this line right here, this line will happen 8 times for this. This line will happen 8 times for this. And this line will happen 8 times for this. So it'll be 8 times 8 times 8. Each 8 is 2 to the third times 2 to the third times 2 to the third. That's 2 to the 9th, which is 512. So if we come back over here in Vim, redo this, and run that, we get 512 as the answer. My expectation for you all on the quiz next week is that you will be able to, you don't necessarily have to do this sort of math in your head, but you will be doing it without a calculator at all. So the quiz will be testing both your understanding of how to get the right formula for these, the runtimes of these algorithms, but it will also be testing your arithmetic skills with the number 2. There's, yeah, the number 2, all these powers of 2 just appear extremely often throughout programming. And so having this ability to do mental math or quick paper and pencil math with the number 2 will pay off dividends for you throughout the course. Any questions on this problem? Yes. Sure. So when we're stepping through this, we always so what I'm going to do here is I'm just going to open up Python Tutor real quick. And let's create a for I in range. Make it a little bit faster. So we'll do 2 for j in range 2, for k in range 2, count plus equals 1, and let's add a count equals 0 right here. And so our goal is to count like how many times does this inner line right here actually run. And so with Python Tutor, you can step through this. And so here we're on line 2, and we go inside this for loop. The very first time we go inside this for loop, that I value is 0 because range contains the numbers 0 and 1. Then we go inside of this for loop right here for j in range 2, and we get j is 0, again, because the range is 0 to 1. And then go into k, range 0 to 1, so k equals 0. And then we finally get to the count line and do it the first time, and we see that count became 1. So the red is the next line to be executed. The green is the previous line that was executed. So we just did this for k loop right here. The red line on count plus equals 1, so currently at 0. As soon as I press next, we'll execute this line, and count becomes 1. The red line goes back to the for k in range 2 because right now k is equal to 0. The range 2 has the values of 0 and 1. So when I press next again, it'll get the value of 1 inside of it because that is still inside the range right here. And then we'll move on to the count plus equals 1. I press next to execute this line right here. The count will go up. Press next and the count goes up. And then we come back to this for loop again. The range here, again, is 0 and 1. We've already done both of those values. So we're done with this for loop. So I press next. Notice what's going to happen to this red line. As soon as I press next, the red line is going to go from the 4 to the 3, not into the body of the for loop down here. We're not executing that again for that for loop because we were done with it. We're going back up here to this middle for loop, the for j in range 2. Here, the k value is still equals to 1, and the j value is still equal to 0. For j in range 2, we've done the 0, we have not done the 1. As soon as I press next, notice the j value is 0 right here, it'll go up to 1. And now we're coming back to this for loop for the new j value of 1. So here, the k now will go to be 0 because we're doing this for loop again for the second time for this loop, and re-executing the count back through here, going back to this for loop right here, and then back to this for loop right here. Now we've executed the j value, all the j's there are, so we'll go up again to this for loop, and now the I value going from 0 up to 1, and redoing all of those steps again with the I value of 1. Coming all the way to the end, we see that the count is equal to 8. So this line right here, adding 1 happened 2 times 2 times 2 is 8 different times. If on these problems, it is very easy to get confused about exactly what's going on, especially once we get to these some of these later problems with lots and lots of nested for loops. You can always go back to the Python tutor. These are just, there's nothing special about it. You can just copy and paste it into Python tutor. And so you have to substitute the variables right here. But after running this command, whatever the contents of foo.py is, you can copy and paste that into Python tutor and step through and make sure that you just understand exactly what's going on that way. Good question. At this point, again, the main thing to take away is this general pattern of nested for loops. You multiply to get the number of times that this inner line right here is going to be run. And I'll say again that right now we're just like actually counting what this, or predicting what this value is. But you can see that this number that we're counting right here is going to be like eventually representing our runtime of an algorithm, that the number of steps that we have to execute is going to be how we're going to measure how long an algorithm will take to run. This algorithm right here took only 64 steps to execute, so it was faster than this algorithm down here, which took 512 steps to execute. So we're building up the intuition about how many steps something takes to execute at this point. And then next week, we'll formalize that with a little bit more math about how long it takes things to execute without these counts. The next, yes, question. I'm gonna pause you. That's like section 5. So section 2 down here, the sequential for loops. This is the key difference. Make sure that you are paying attention to this on the quiz, that these for loops are not happening inside of each other, but one after each other. So this for loop down here is not going to happen for every iteration of this for loop up here. Instead, we're going to do all of this. And then once all that is done, we're going to do all of this. So whenever you have sequential operations like this, you do not multiply, but you add. Add sequential operations. This first operation takes, or will give us a count value of 8. We run this count value 8 times. So we get an 8 right here. This second one is the same exact thing. So it'll also take 8 times, get an 8 right there. And so the final, add those together, and we'll get 16 will be the total value of count at the end. If we add more than just 2, so here we have 3, then it'll be 8 plus 8 plus 8. And so that'll get us 24 as the total amount that count comes out at the end. Any questions on the difference between a sequential or a nested for loop? Yes. Question is, what if we combine sequential and nested for loops together? And that is our section 3 right here. When you have things combined together, you just consider them one at a time, and then you'll get the right result. So here, this line right here will happen just one time. This line right here will happen 8 times. This line right here will happen 8 times. So 8 times 8, and then there's only one count right here. So that whole thing together, multiply because they're nested, gets you 64. Now we're down to this second for loop down here. And here, I'll do this one in a different color so it's clear what goes with what. Here, there's 2 counts inside. This count plus equals 1, this count plus equals 1. So we're going to add 2 each time, and we're doing it a total of 8 times. So it'll be the number of for loops that we're doing, 8 times what's on the inside. So 8 times 1 plus 1 equals 16. And then there's one additional count here at the end. These are all this for loops, this count, all sequential. So plus an additional 1 at the end for this blue right here, plus 1. And if we add all that together, then so 64 plus 16 is 80, plus 1 is 81. And all these problems, you can verify your math. You did your math correctly, and you understood everything correctly by just, again, typing it in and making sure that you get the right number at the end. But when you have combinations of things, again, it's multiply for the nested things. Do those first. Just start from the top to the bottom. So here, these are at the top, so I do that first. Then do this next for loop down here. There are 2 counts inside of it. So rather than just 8 times 1, rather than doing this only 1 time for each for loop, it'll be 8 times 2, 2 times for each for loop. So 16. And then 1 for this very bottom one down here. It's not inside of a for loop, so it's just 1, no multiplication. Add all 3 of those things together, and you get 81. Any questions about that? Okay, I'm gonna skip a bunch of problems so that you'll have some to do on your own and practice. And now we're getting into the question about what if we have multiple variables instead of just one variable? So in this section 4 right here, I'm calling these simple expressions in multiple variables. I've created 2 variables, this in and this m value right here. N equals 8, m equals 4. So when you're doing the substitutions down here, you'll have to be careful about what number goes in which spot. Here, this is the m is a 4, the n is an 8 right here. So now it's not, or the 2 numbers that we're multiplying together are going to be different numbers right here. Multiply those together though, and you get 32 times that will happen. Any questions about what happened here? The difference in this section is now there's this new variable right here. And so when you substitute, you have to make sure that you're being careful that you're substituting the right number in the right location. But once you substitute that number, you know that this outer one will be 8, this inner one will be 4, and so you multiply those together. Any questions? Okay, let's do one more, little bit more complicated one with more variables. Yeah, we'll do this problem number 11 right here. So the first thing that I'm going to do, I'll do the substitution in here. So this line right here, this will happen 4 times. This line right here, this will happen 8 times. This line right here will happen 4 times. I'm doing it backwards. Yes, thank you. So the n value is equal to 8, and the m value is equal to 4, and 8 right here. And then before I I could go down and keep doing the substitutions down here, but I'll just simplify, get my answer for this full for loop expression before going on to this one down here. So this one right here happening 8 times, one thing inside of it. So 8 times 1, that's just equal to 8 for that whole expression. Here, 4 times and 1, so that whole thing just equal to 4. And then we have this plus equals 1 right here. So I'll do a 1 right there. And so between this whole section, all of those things are happening sequentially with each other. So I'll add those up, and adding those up, we get that that whole thing is equal to 13. 4 plus 8 is 12, plus 1 is 13. And now we have, we're doing something. The inside of this for loop costs us 13. We're counting 13 times, adding 1 13 times. And so the outside here, we're going to repeat this 8 times. So we're going to multiply because this is inside the for loop. It's nested, so we'll multiply. We have to compute 8 times 13 in order to do this. 8 times 13. So this is getting into maybe a little bit harder of math, but that's like 8 times 10 plus 8 times 3. So 80 plus 24. And we get 104 times that this first for loop right here, everything. And make it exactly clear what the red is covering. All of that right there should be 104. Any questions so far? Yes. Exactly. There's just a count right here of count plus equals 1. So we just add the 1. Yeah. And then yeah, this is 4 because you can think of it as we're doing the for loop here 4 times. Inside the for loop, we're doing something 1 time. So 4 times 1 equal 4. If there were like 2 or 3 count plus equals 1s, then I'd have to add 2 or 3. Yes. Yeah, so the question is, why am I just counting this 1 time and not 8 times? The reason it's proposed to do it 8 times is because it's inside of a for loop that's going to happen 8 times. And the answer is that I'm eventually going to count this 8 times. But first, when I'm in the green right here, what I was counting is just this sort of section of code. If just this section of code was being run, then it would be 13 is how many times I'm adding to count in just the green section of code. But then I'm going to run this green section of code 8 times. And so I'll multiply 13 times 8 for this red section of code. How many times the count will be run in the red section of code. So it's easiest just to think about like the inside of a for loop, do all of that in isolation by itself, count how many times that's going to happen, and then consider how many times is the entirety of the for loop going to happen, rather than trying to consider each one of these things independently with the for loop. There are, yeah, ultimately many ways that you could go through this and get these and do this math, get the count number. Any way that makes sense to you is totally fine for the quiz. That as long as you get the right answer at the end, you'll get full credit. But you'll find it easiest to always work from the inside of for loops to the outside of the for loops, and then from the top to the bottom. Good questions. Any other questions so far? Okay, down here, the inside of this for loop, that's going to happen 3 times. Count will get 3. The m up here, let's do the substitution again. The m being 4, this m being 8. And so what's going to happen in, did I get it backwards again? Oh, thank you. They're both M. So M and M, 4 and 4. This section of code right here, the counts will happen 12 times. Adding a 1 right here for this. So that whole thing will be 13. And then this whole block right there, we'll have the 4 right here times the 13 will give us 52. That's 4 times 13. 4 for the number of loops, 13 for the number of counts inside of that for loop. And then this green box, this outer green box, and this red box up here, they're sequential. So we add them together. So it'll be the 104. Four plus 13 will give us 117, as what the final answer here would be. Thank you. This, I saw the 13 right there because I wrote it backwards. This should be plus 52. So this right here would be 156 as the final answer. Last weird thing for the quiz about what's going to happen. Let's see. So here's a problem with 3 variables. You'll have to be able to handle that. But you can have expressions on those variables as well. So here I now have 3 variables, n equals 8, m equals 4, o equals 2. And how many times this is going to happen right here, how many times this for loop will execute is m times o. So m is 4 times o is 2. So that loop right here will happen 8 times. And then this loop right here, n is 4, m is 8. 4 times 8, that will happen 32 times. And so now all 3 of these things are nested. That times that times that. So 1 times 8 times 32. 8 times 32. So 2 to the 3rd, 2 to the 5th equals 2 to the 8th. And that's equal to 256. And so that should be the final answer for this problem. If there are, so the key takeaway here is that if there are math expressions like this, you'll have to evaluate those math expressions before going into those sequential parallel logics. Question? Last thing, so what things can change here for the quiz, the actual quiz that you're going to have. The math operations that you'll be responsible for: addition, multiplication, exponentiation, and then any combination of sequential or parallel code like I have. These n, m, and o values, any power of 2, you're responsible for. I think that's a good spot for us to stop for today. If anybody has any questions about this or anything else, I'll stick around after class until all those questions are answered. Otherwise, I will see you all on Friday.